Welcome back, everyone, to another episode of Data Analytics Chat, where we explore different topics in the data science and engineering world. Today, we're going to be discussing the topic of the evolution of DBA to data engineering. As you probably will guess, it's been a big change, especially when I first entered the market. There's a lot of DBA type positions, and it does seem like it has evolved. Today we have Brad Lowenstein joining. He is the head of data engineering for AWS Finance. So welcome, Brad.
Thank you. Excited to be here.
Yep, likewise. So do you want to briefly introduce yourself?
Sure. Yeah. My name is Brad. I'm a data engineering manager in AWS Finance, as you mentioned. I've been in data engineering my whole career, so I've seen it evolve quite a bit. I'm excited to talk about, the evolution from the DBA to the modern data stack, the modern data engineering role. It's been quite a big evolution over the last several years. I'm excited to talk about, I think the cloud will be a big part of this conversation. So excited to jump in.
Brilliant. So I guess for yourself, obviously, in the last 2 years, there's been a massive boom, isn't it, in this space? What made you get into the technology market and data engineering precisely?
Yeah, good question. So I was always interested in tech and what was going on in the tech world and just with software engineering and just how products and tech products that we knew and loved, how they were built. I always wanted to dig in, see what was going on behind the scenes, and eventually just my curiosity coincided with a job where I was working at the time in finance. Basically, what was needed was we had all these great data scientists working on these complex problems with machine learning, complex multivariate regression, you name it, and the data was the biggest problem towards delivering on our goals. Is how do we get the data available on time? How do we get it clean in the format we need? Those problems we just kept running into. And that became the biggest need, and I stepped in and was curious to learn how do we solve that, and took off from there.
Yeah, and still a big problem for companies nowadays.
It is, yeah.
It's ever evolving, isn't it? So, it's always going to be challenges there. All right, brilliant. It's great to have you on the podcast. Obviously, I guess the last couple of years has been the boom of Gen AI. It's created a lot more data, especially in different formats. So I guess cleaning is quite important now for businesses, isn't it? Get it into the right shape. Just getting, there's a lot of data within companies, but then I guess the next challenge is what do you do with it as well, isn't it?
Yeah, it's interesting talking about that because you think data, why is this different from software engineering where we're building an app or we're building maybe a website, or you think about, I don't know, Google or Facebook, those are apps, they're well tested, and they don't have outages often, I should say, at least anymore. They're well tested, oiled machines. Why is data so different? And I think what it comes down to largely is it's relatively newer. And then it's also it's harder to sanitize your inputs. So with a web form, if you're taking usernames and passwords, whatever, you can sanitize them to some extent, what you're expecting. In the data world, you can't really do that in the same way. It's harder to anticipate the wide array of how things can go wrong. There's still some bounds of what can happen, but it gets very expensive to say, let's check. Or expensive can mean a few things, by the way, in terms of cost or time to check and sanitize every single value before ingestion. There's different paradigms that are coming out to deal with this type of thing. I think it's the right audit publish framework you're seeing a lot more of. So there's different ways people deal with this, and we can dive into those. But yeah, it's definitely evolved quite a bit. And yeah, I'll pause there.
Brilliant. Now, okay, cool. Let's jump into the first question. And can you briefly describe the traditional role of a database administrator and its primary responsibilities?
Yes. So a DBA is going back a bit, and bear with me, I'm not reading from a job description, or I'm sure everyone defines this somewhat differently. But I think of a DBA, I think there's certain responsibilities like maintaining a database, making sure your versioning is up to date, hardware is and disk space is all operating normally. You're not having disk failures. Your hard drive is not filling up. You're staying up to date with versioning. And then that's the more underlying systems maintenance. And then that it goes all the way through to making sure tables are defined correctly, queries are running efficiently, data types are correct. So we're talking about a lot of the data, the maintenance of a database, is database administrator.
Yeah, like more of a support type role, I guess,
Yeah.
sort of
Yeah.
thing.
A little bit more removed from the business
Yeah.
context, more like how do we make sure that this application, which is what a database is, how do we make sure that the database is up, it's healthy, it's performing?
Cool. And then, so what's been the technical advancements to drive this evolution from a DBA into a data engineer?
Yeah, it's a good question. And I think there's a few things all happening around the same time, but one of the bigger ones would definitely be the birth, evolution, and adoption of the cloud. With AWS is obviously one that I'm more familiar with and gonna
Yeah.
talk about mostly. But with AWS, if you're using, let's say, Redshift, which is, I think we're talking about 2013, and then adoption drove after that. But you don't have to have someone worrying like, is the disk full, or did one of our nodes or our hard drive, is this going to fill up? Is this going to fail? That's all abstracted away. These things, the word abstraction is important. Like, these things still come up and it's something that can cause issues, but a lot of those details are abstracted away, and you can just say, all right, someone else is dealing with it. It's not my problem today. And every so often those abstractions can be leaky, and you'll see, okay, a node fails, and we actually get those emails. I'm sure, hope everyone is signed up for those alerts, but a node will fail, and then you get an email, or ideally what would happen, let's just say, is your ETL is running overnight, and you wake up in the morning, everything's run successfully, and a node failed. It was replaced 10 minutes later, no big deal, auto recovery. Whereas in the previous world before the cloud, DBA would be responsible for waking up, getting paged, waking up, figuring out what's going on, talking to someone in their on-prem database setup, whatever that might be, or if it's a rack in the closet, they'd have to go figure that out. So it's a very different setup.
So do you think, cloud's been the main driver, you think?
I think that's a big part of it. I also think that there's, when I say these other things going on, more investment in the data world, or businesses want to invest in data analytics and have these more mature data systems. And if we're relying on big data analytics as a top tier business goal for different businesses, it's different. But you need to invest in having a top tier data program. So you need reliable runtimes, you need tested data, you need QC, you need dashboarding. All of these things come together, and you need a new role to ensure that all of that runs smoothly. And that's the role that, at least in my opinion, that a data engineer steps in to fill. There's lots of different little, call them niches, like a analytics engineer, machine learning engineers, DBAs. I'm not saying they're gone, but there's less of a role. Maybe it's more of a niche now. There's data BIEs. There's lots of different roles that exist where maybe there was just a DBA and a BIE before, or something like that. I'm using a lot of acronyms. Do you want me to go through what all that means?
That's fine. Audience should be fine. But yeah, so I guess it's just evolved, and then their roles into another job thing as well.
Yeah.
So you said.
Yeah, it's the data, as you nailed it. Like, the data sets are growing. The size of data that is stored in the world is growing. There's just more and more investment in this area. So there need to be more, it's not necessarily, but there are, because there's more specialization, more investment. There are more roles just to deal with all these different specific needs you might have. A startup might not need DBA, data engineer, analytics engineer, ML engineer, but a company like Amazon, obviously, we have every problem you could have, name it, we have those problems. So we do need a lot more job families and specializations. I've been at startups where it's just a data engineer and a data scientist. It can vary depending on the need.
Yeah, I definitely think, obviously, like, the more investment now, especially when there's massive investment now, isn't it, around big data. Just with data engineering roles we get, it's a lot more like Spark has been a massive driver. That's been a massive change in job specs. So like Hadoop, all them type of technologies is coming out now. So there's definitely that massive investment from businesses.
100%. I should have mentioned that earlier, that distributed computing, which Redshift kind of goes along with that as well, but distributed computing is a whole new skill set, different languages that are needed, different familiarities with these frameworks, hence these different job families and job titles as well.
Yeah. I mean, now you get like DevOps is fairly newish, right, in my opinion. Obviously, it's been about, but it's obviously a new role that's evolved. But now you're getting like data ops and things like that. So it's constantly going, isn't it? It's constantly more jobs being created, basically, more roles.
Yeah, and a name is only as useful as what people know it by. So if you keep coming up with new job titles and names and so forth, but I think the industry might lag a little bit behind and play a little bit of catch up because I don't know what a data ops role does. I can imagine, but it just depends what people find useful.
Yeah. How has the required skills and competencies evolved from the DBA role to a data engineer?
Yeah, they've definitely changed. It's quite a bit different. With a DBA, we were talking about that before, but it's a lot more of this familiarity with the lower level systems. So how do you swap out nodes is the example I keep harping on. So there's familiarity with maybe Bash and version updating, like how do you update the operating system, things of that nature. As you talked about with the cloud, you don't necessarily need to do that as a data engineer working with AWS or there's other providers out there. So that's one thing for sure. We don't need as much of that familiarity, but it's still relevant. I'm not going to say forget it. It's always good to know those things, and it does come up more than you think. And then on the flip side, there's a lot more that a data engineer would need to know. Like we have job requirements that you need to know Python. Scala is always useful. Those are, in terms of coding languages, those are useful. SQL has always been useful. It's always a requirement before and now. And then I also say, distributed computing, Spark, Flink, Airflow, which is an orchestrator, it's a little bit different. But do you have familiarity with all the modern tools and frameworks? And do you know how to deal with memory management in Spark? Those types of skills that people can learn, but are definitely useful things on the job.
Yeah. No, so there's a lot more felt, especially when it's more like database work. Not now, it's a bit more got that coding element to it, hasn't it?
Yeah. So it's interesting because,
and obviously that I guess obviously AI and ML element to it, isn't it? You got to have that more knowledge in that space because before it was just more know your database.
Yeah, where DBA could be, let's make sure this database is operating, and that's where the responsibilities end. I'm not saying that's always the case. I don't want to say they're just narrow-minded on that, but traditionally it would be more focused on, is this database up and running? Are we getting performing queries and operations out of this? Now it can be a little bit different where I've had this very roll-to-roll company, but you're a lot closer to the business context. And when you're data modeling or understanding, okay, the customer, the business needs this data set at this time at this SLA, and you have to understand, okay, our system doesn't work that way right now. What are the ways we can compromise or figure out how to re-architect the system, and how can we relate that to the business and figure out, they say they need it every hour. Is that actually true, or do they just need it every hour from 9 to 5? So figuring out what does the business actually need, or trying to understand to data model is also understanding what's the business context here, and just getting a little bit closer there. I think it's not to say DBAs don't do that, but I think with data engineering, you get a little bit closer to that.
Yeah. Okay. Cool. So that moves on to the next one. How's the responsibility? What new responsibilities does a data engineer have as opposed to DBA?
So I think it's a little bit different. It's nuanced, but I think the data engineer, and again, it varies in different places, but I think it should be that the data engineer is responsible for ensuring the integrity and the timeliness of that data. So where a DBA would say that I own the hardware, and that's the hardware and maybe some of the physical tables and things like that. The data engineer is more responsible for delivering an end product of, is this data set here? Is it correct? And is it on time? So there's a little bit more responsibility. That's how you get closer to the customer, is what I was saying, alluding to earlier. So yeah, it's a little bit more responsibility there. And also we talked about this earlier, but as a data engineer, you're not patching versions and looking at a lot of those more you're doing that, but it's less of the less emphasis there. A data engineer also, like I should mention, you're marrying kind of the concept of a DBA and a software engineer. So you're taking a lot of that history of what the DBA is doing and taking in the more relevant and beneficial parts of the software, the SDE role, the software app role. So one thing that I always emphasize is how can we bring in the software development lifecycle into the data world? It's been very hard. There's lots of attempts, lots of different companies and people doing it in interesting ways, but it's been really hard. But I would say, regardless, checking in code, so familiarity with Git, CI/CD, unit testing where possible, rollback, failover, all those things that are, again, not like new. I don't want to say like DBAs didn't do any of this, but more kind of influence from the software side of things.
Yeah, definitely. Even from just looking at like job specs that we've had like, over the years, like before it used to be even data engineering roles, like it used to be more on the bit like the business intelligence data aspect. But like you said, now it's definitely moving to like more of the software skills, and that's obviously where a lot more upskilling is from businesses, because if you're asking for this, not everyone's got it, have they? Because if, like I said, every business is so different at the minute, so many different technologies, you can't just go to another company and fit in. You need to be upskilling and need learning and evolving. Tech gets a bit wider and bigger as well.
Yeah, no, it is interesting. Some data engineers, and everyone's different. So some data engineers are definitely more on the software side of things, of building data-focused apps or websites or dashboards, whatever it may be. And there's others who are more closer to the ML side of things, and others who are more core database. So there's some room and flexibility within that role of how you, different flavors of it, of how you interact with the business.
Yeah, definitely. And so, you touched on it. What's the challenges then moving from being, I guess, the traditional DBA into data engineering?
It's a good question. Yeah, as a DBA, I don't want to say upskilling, but it's learning those new skills. So like you may be learning Scala if you're working a lot with Spark. Obviously now the Python SDK is a lot better. So Python, Scala, I'd say a lot of these new database technologies. So Redshift might be a little bit different as a DBA. So learning how to use Redshift rather than Postgres, using Spark, we touched on earlier. Streaming technologies can be a lot different. And then orchestrators, so Airflow, things of that nature. There's a lot of different orchestrators out there as well. And then, yeah, there's the whole modern data stack, which is used to varying degrees at different companies. So there's DBT, Fivetran, all those, lots of different complicated things there. And then also the whole BI and visualization world of things. Tableau, QuickSight, Looker, just getting familiar with how to connect and how to really tie it back to the business. That's that last mile of how do the actual business users, whether I work with a lot of PMs or salespeople, how do they look at this data and how do they make sense of it? So those are just a lot more modern tools.
Yeah. So there's a lot more to know.
Yes.
Yeah, and learn.
Yeah.
And I mean, it's always evolving. Like new things coming out all the time, isn't it?
Yeah. Yeah. It seems like we had this trend a few years ago and it's resurfaced with all the LLM models coming out, but it's every quarterly earnings call you hear, they're talking about data analytics. They're talking about, now it's ChatGPT. I remember, I think this was like 6+ years ago, they were just ML, whatever, everything had to be ML. So yeah, companies are investing in this. They're expecting that investment is going to bring a return. And that just brings with it different SLAs of maybe it was okay before. And I think this comes from two sides. I think one, the technology has improved. So our expectations of what we get out of that technology is a lot better. And then on the other side, the business is demanding more performant data operations. So both of those can meet, and we're getting SLAs on data sets, and we're getting weekly reporting on big data sets where 10+ years ago, that wouldn't be possible. Maybe these data sets 10 years ago would only be used for strategic data science projects where we'd be looking back maybe once a quarter and doing this kind of longer range, kind of deep dive analysis. Now we're doing that basically every day, every week. So the expectation, the goalposts have shifted.
Mm. And I guess you mentioned earlier, like, as in this, the data engineering roles gets close to the business. I guess you've got to be able to communicate to the business then in different business units, because obviously everyone's not going to be tech savvy. You've got to
Yeah.
be able to communicate that in a non-techie way. That's obviously translates in a understandable manner for the business people.
Yeah. You can imagine there's a lot of times where if a data set is late, you have to say to a business person who was just trying to, let's say, deliver a sales model, or they're trying to do their job and they don't understand why the data is not there, why it's not ready. And the expectations they might have could be software development of why is this app not up? Why is the website, or sorry, like in the software world, the app is always up, the website is always working. We're talking 4 or 5 nines of availability, but then you go to the data world and you have a different experience a lot of the time. If the data sets are late or they're wrong or there's more work to be done oftentimes. And that can often just be, yeah, we touched on this, but it's harder to ensure data accuracy on large data sets. You get in a terabyte of new data, and how do you audit it and sanitize and reform all that data and ensure that it's exactly what you expected? Maybe you can validate, I don't know, the rows sums are different or the deviance from last week, but maybe the data set is more skewed than last week, or there's some kurtosis, or who knows what could happen. But it's really hard to validate all of the expectations that you have of a data set without kind of listing each and every one of them, which can be it's not unsolvable, but it's a very hard business problem to upfront say, here's a data set, let's list out every single thing we're assuming. I've had instances in a business where one of those assumptions was that the data set wouldn't be null or would largely have valid values. A whole model was built, and then after a year of development, turns out 80% of the values were null, and no one thought to check that, and then a lot of that work was wasted.
Yeah,
crazy. It's hard you can't just open that data set in Excel and look at it. You can look at samples, but the sample obviously doesn't tell the whole story.
Yeah, definitely. I mean, it's bigger the business, obviously the more challenges as well, isn't it? Like, obviously the more data, and so you can't just go on one data set like you mentioned.
Cool. Data cataloging. How do you know like what data sets you even have? I can say that's a problem. Been on various teams where we run into this of we have 2 or more of the same data set, or the same data set with a different column or slightly different filter. And it's because team C and team D weren't talking. They don't even know each other. They might sit in different offices, and trying to get all of that to be surfaced and make it really clear to everyone. So data dictionaries, data cataloging, data lineage, all of those things there's more and more tools out there, but driving adoption can be hard.
Okay, cool. And then you mentioned earlier, obviously, cloud's quite a big component to this. How's the increasing adoption of like cloud platforms impacted the evolution of the data engineering role then?
Good question. I think it's different. It's interesting because in the old world, maybe you'd partner with a DBA. As a data engineer, you'd say, okay, DBA is responsible. There's some person out in another office, maybe, who goes into the data warehouse and make sure everything is running well, or maybe it's who knows. But there's one person or a team that you're working with. Now it's if you submit a ticket to AWS support if something's gone wrong, or you trust, or there's a lot more abstraction again. So sometimes those abstractions can be leaky and a node is replaced, or it's hard to know exactly what's going on or why performance is different. But again, you have the ease of not having to go in and worry about all of these underlying details. You can just say, okay, AWS, someone's dealing with it. I don't have to worry about this. Hands off, which I think is, and it seems like the market has said that's a bet that a lot of people want to, or a trade-off a lot of people want to take. But it is different. Yeah, like I have to say, like I've worked on teams with the DBA, and I miss having that relationship with that person. You'd call them up and say, hey, I think something's gone wrong. And they're like, oh yeah, let me go look at what's going on. Or dive deep together. It's definitely a different setup. So
Yeah.
we're seeing that job get, if you will, automated away.
Yeah. So it's just more the scalability and there's the flexibility now, just to obviously pass it to like a managed vendor and just
Yeah.
just minimize the workload, doesn't it, for people?
Yeah, and you can talk about provisioning too. I used to say, okay, we need a new workload coming on. We need 20 more nodes or whatever it may be. That used to take 6 months, and you'd have to submit tickets, and there's red tape, and there's all sorts of work required to do that, and actually finding where we're going to put that in. You don't have to do that anymore, which is great. But yeah, it's great power, great responsibility. You have to make sure you're doing these things effectively. You can run up a large bill really quickly. So you have to just be more aware. There's more responsibility on the data engineer in that way. So it's changed a little bit.
Yeah, even in the cloud. Obviously, your company may be different. Obviously, with other companies, they normally had just like one cloud platform, and then now companies have got multiple cloud platforms. And then, so I guess even data engineer, you got to have not just like AWS, maybe Azure, GCP.
Right.
Like you got to have that knowledge now. This again, more knowledge, more understanding. I know this they obviously do the similar things, but it's still there's differences, isn't there, to them?
Yeah. Yeah. It's actually an interesting point you touch on, because it's not largely, but it's somewhat shifted in the cloud world from where you could before work in an open source world of Postgres or a lot of these databases. Download the binaries and install and run on your own. You could look at the code that was running. With a lot of the cloud providers, you can't really do that. If you look at something like EMR, that's using Spark, but if you look at Glue, it's also using Spark, but again, like there's more kind of magic going on there, so you don't really know what's going on all the time. And then, if you look at other providers, I don't know, you can look at Snowflake, is a little different. It's, again, you don't really know what's going on all the time, which has, again, its pros and cons, because there's likely new features in there that make things run faster or more optimized, different connectors that simplify your life. But then when something goes wrong, often it's hard to dive in and see what's going on. Submit a ticket sometimes, and you're wondering, is someone going to fix this? When is it going to get fixed? Whereas open source, you can write the code that you want, merge it yourself, follow the release, or just work on a branch. There's a lot of different trade-offs there.
Yeah, no, it's definitely just doing this like the key thing is just it's constant, continuous learning sort of thing, or consistent development as well, or continuous improvement. I think is key. It's just that everything's you complete one task and then something new comes up and then it evolves into something new, and you just got to keep going with the flow, haven't you? It's like data journey is, I think, a good name for it. Well, I guess what's for a data engineer? What are the key or essential tools and platform to use in today's market?
Yeah, and also just to circle back there, there's lots more tools, technology. It's a growing space, lots of investments. You're seeing, whereas 10 years ago, you might have to custom build a, I don't know, QC tool. Now there's lots of options out there that you can buy off the shelf. Some of them open source, some not. And we are seeing kind of a evolution in recent news back to more open source or open data models, with the adoption of, I think we don't have to get into those details, but there was some news, I think a month ago, of a few data providers going with open data specs rather than these closed private data modeling, data formats. Yeah, there's the modern data stack you had asked about. Different people define it differently, but generally you can look at tools like Fivetran for data ingestion, which is just a way to connect to lots of different data sources and then centralize that all into your data warehouse or data lake. Whereas before, you'd have to write all these custom connectors, and this was an issue that I would have sometimes. You switch jobs, switch teams, and all of a sudden you lose all that. So it's great to have one service that does all of that. If you're familiar with it, you can use it wherever you are. It's a cloud service. I haven't used it, but I've heard good things. It seems like a lot of different people are using it out there. It's definitely becoming an industry standard. In terms of warehousing, I touched on ingest the data and then you store it somewhere. Redshift, BigQuery, Databricks has its own solution, Snowflake as well. You could use S3 or different object stores. So there's lots of different options there as well. And then the transformation and metric stage has gotten a lot of, I've been pretty interested in following that myself. DBT is definitely like the first mover in that area as I see it. And they've definitely taken an early lead, but there's definitely, it seems like there's been some slowing of adoption there. I've seen some competitors. SQL Mesh is a new tool I was just looking at. It seems pretty cool. Similar, but like it's just designed thinking about some of the problems people are having with DBT and just solving those fresh from the ground up. So that's been pretty cool to observe. And then, yeah, the BI tool. So once we transform, I should actually back up. In data engineering, there's a common paradigm called ETL or ELT, but there's extract, load, transform. So extract would be Fivetran, where you ingest certain data sets to your warehouse and load them into, let's say, a database or a data warehouse further down the line, or data mart maybe. And then transformations is what I'm talking about with DBT, SQL Mesh, a few different technologies out there, but that's about massaging the data, making it into the format that you want specifically for the business or data scientist or whoever the end user is. They'll just say, I want like a certain grain and certain columns and certain QC metrics applied. So that's about getting it into the right shape for them. And then finally, the BI layer, which is about how do we, as a business, and again, BI is one use case, but how do we visualize this data? So are we going to put it in Excel? Are we going to put it in a dashboard like Tableau, QuickSight Looker? Are we creating a data science model? There's a lot of different kind of usages that you could have, but there's definitely a lot of players in that space too.
Yeah, no, that's definitely us. Like I said, we said earlier, I mean, each business is different. Everyone's got different ways, and also you got to be able to integrate that as well, different layers, and it's just endless tools out there, isn't it? Really, and it's just constantly evolving, improving, and changing. It's endless learning for you people involved in the data engineering world.
That's what we've signed up for. Yeah, this is fun. That's exciting.
Yeah, no, definitely. You want to keep learning, because I think, especially in jobs, when you keep doing the same thing, if it's like Groundhog Day, you get same old, isn't it? And
Exactly.
if you keep learning every day, it's obviously you're challenging yourself, it's good to your mind, and you're learning new things as well. So you are evolving as well, which you want to be doing as a human.
There's no lack of problems in the data space. So there's lots of, if anyone out there is interested in becoming a data engineer or learning more about the space, it's moving very rapidly, lots of new tools every day. Definitely, yeah, it's a place where there's a lot to learn, a lot to grow.
Yeah. Moving to my next question. What advice would you give someone looking to move into data engineering? Because I've seen you've seen data scientists move into data engineering. Obviously, the whole subject in general, data's gone wild now, isn't it? Like everyone wants to work in the industry. So it'd be good, obviously, and it's hard looking at, say, like graduates. It is a challenging area for them to get into business, because a lot of companies do want the experience already. So it'd be good to get your advice to people looking to get into the market.
Yeah, it is a hard one. It's difficult if you're a software engineer and you want to go work at a company as a software engineer. You can build an app or a website or whatever it may be that, like, some automation, and maybe you host it on AWS and it costs you $15, maybe up to 50, but not that much. If you want data engineering experience, you can run a toy example with a gigabyte data set and it'll cost $5, $10, $20 maybe, but that's not going to teach you as much about, and you're not going to run into a lot of the issues you run into running a large data program or running on big data. It can be hard to get those toy examples going and get that same experience until you start, say, loading up with a terabyte data set, at which point you're talking like that could cost you $1,000 to operate a Redshift cluster or run a Spark cluster, whatever it may be, which as a student, you're not going to want to go spend that amount of money, I imagine. There are student credits and different programs out there to help with that, but it's definitely, there's a barrier. And then the other thing I'll say is, if you're running a data pipeline, it takes an hour, like that is a time investment. And again, students or people learning this might not have the time or energy or ability to invest that amount of time. And that's part of what makes data engineering a unique area for testing as well. Yeah, I'd say do as much as you can with what you have. So figuring out like, can you force a certain, even with a gigabyte data set, can you create a small cluster and make it so that the data set has data skew, so you run into some memory overload issues and learn how to deal with that. It's going to be a little bit different, obviously, because you know what the issue is ahead of time. But just finding ways to play around with a lot of these tools. I don't think, I mentioned that it is different, but I don't think you need a terabyte data set. It's okay to play around with a gigabyte and just get familiar with the APIs, understand what everything is. I think reading a lot of these white papers for the Hadoop HDFS white paper when I started was really helpful to understand, okay, this is what's going on with distributed computing. This is why it's harder. There's a lot of things going on under the hood that are often abstracted away that you luckily don't need to know about. But it's good to maybe even try creating your own distributed system, which every time I think, oh, I should go, recreate this or that, I learn, don't do that. It's way too hard. But I think playing around with that, running into those issues and seeing why some of these frameworks are so great can be really helpful, or just understanding the trade-offs and what's going on is really helpful. So yeah, it's a play around.
Yeah, no, I think obviously we've done hiring in the software field, and for juniors, they can go on GitHub and create something, and that's illustrating their skills. But yeah, like that, the data is obviously completely different beast.
Yeah, for sure. And then if you want to talk about ML, it's you need a GPU, and that's going to be really expensive. There's definitely toy examples you can go with that are not going to cost as much.
Yeah, brilliant. Oh, great. That's some great advice. So to finish up then, so looking ahead, what trends do you anticipate in in the data engineering role? How is it going to evolve?
Yeah, it's definitely going to evolve. So that's the one guarantee. Lately, it feels like the biggest theme going on now is everything needs to be an LLM and everything needs to go through ChatGPT or something similar. I'm excited to see how that plays out. I think there's some really exciting applications that I personally am just like, wow, that would make my job so much easier. So we'll see how all of that works. I don't know yet, but I definitely like the skill set continues to expand. Of now everyone's asking, hey, can you connect, I don't know, your database, or can you load this, whatever it is, like your documentation into this LLM so that we can ask business questions, or we can get guidance on how to write the best queries. Maybe we can populate a data catalog, whatever it may be. Lots of applications there. So I'm not to say that a data engineer needs to know how to train a model, but at least how to use it or how to run it. That's definitely becoming more and more common.
Yeah. So you think the big driver is going to be LLMs?
Yeah, and this is happening. It's not actually new, but ML engineering, whether or not it's for LLMs, familiarity with GPUs and how to run different machine learning operations. Yeah.
Brilliant. No, I think it's obviously, even when the sort of the boom happened, like what's it, just over a year ago now, or over 18 months ago now, you just thought it'd be a massive change of impact, didn't you? But obviously then you get under the hood and it's like, actually every company's got to get their data in check. Because there's so many use cases out there, isn't there? But in the day, look, businesses now have got the big, it's been a blessing for companies, but it's obviously probably created you a lot more challenges. And then obviously you realise you've got to get your data in the right format, you've got to get in the right context, and it's a lot more work to get to that stage next, isn't it? So it's going to be, in a good time in the future where businesses are ready to actually use LMs or these ChatGPT devices, apps to actually assist you in the right manner.
Totally. Yeah. Yeah. And we can dive in further on that. It's there could be use cases that help the data engineer do their job. There are also other use cases that help the data engineer's customers do their job, and they need the assistance of the data engineer. Both of those are a little bit different in how you'd be using the tools, either as a user or a producer. But yeah, there's a lot of exciting opportunities there. So it's tough because you want to say, oh, this is going to solve that problem. I like to stay away from that. We're not every time a new technology comes out, it's okay, this new problem is solved. And we have that issue of a solution in search of a problem. I don't think we can just say, throw an LLM at a dashboard and say, okay, we don't have to worry about creating dashboards anymore. It's going to solve all these business problems. Or use an LLM on our Spark logs and say, okay, we're going to self-diagnose and fix all of our out of memory issues or whatever it may be. It's really hard because as we know, like LLMs tend to hallucinate. And if you're, let's say, running a BI query and you want to know the sum of revenue over a given month, if that query is running correctly, your answer is incorrect. And maybe it's helpful to generate like a first go at a query, but you definitely still need a human in a loop to say, what are we actually doing here? Does this make sense? And if not, like you have the capability to be off by an order of magnitude. It's not just you're eating pizza with glue is really bad, but let's say you use too much flour in your pizza, that's smaller stakes. You can recover from that. The pizza's going to taste bad, but if you're reporting, and we're talking revenue with these numbers, it's not life and death, but if you're running studies on new cancer drugs and you want to know what the impact is or the efficacy of a certain drug, if you're off by an order of magnitude of what the dosage is, that's a real problem. So it's important to make sure that we know exactly what we're doing.
Yeah, no, definitely. But no, definitely exciting times ahead because there's a lot of changes going to happen, isn't it? Really, there's a lot of things out there now. That's obviously it's not going to happen overnight, is it? Because there's a lot that needs to be solved. And I guess even when you add LLMs to the mix, it's going to probably create more problems. Not problems, but more challenges because everything's different, isn't it? When you change, there's always something new comes up. So changing that technology mindset, and then also just the operations side of things is challenging for businesses as well.
Yeah. Look, the idea is that you're solving more business problems, or you're solving them faster, or you're doing something to make the business run better. But yeah, it's a new paradigm, it's new technology. There's gonna be learning involved. So ideally, that's all helping. We're not just creating more problems that we have to deal with, but we're doing new things that help us deliver our product to our customers faster, better, whatever it may be. So as long as it's in that effort, I think definitely go forward with all this.
Brilliant. It's been brilliant having you on the show. Thanks for your time, and you provided some great insight for the listeners.
Thank you.
Cheers, Brad.
All right.